All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue working on the auto clipper, which I'm now renaming to the content pipeline because I couldn't think of a better name, and I decided to go with the name that best describes exactly what this is. And this is essentially, you know, a content pipeline. At least for my purposes, it is basically a content pipeline. Um, what was I? Oh, yeah. Okay. So today we're going to continue working on the content pipeline. Yesterday, and also today before today's stream, I have been working on. I was sitting and thinking about the logic that I was going to follow, or the logic that I was going to build for for updating the VOD titles in each of the bundles. And initially, what I was thinking was that I'll somehow try to incorporate. Oh, I also have this to do. I guess I can delete it now because yeah, I initially I thought about adding it into the batch build bundles script. I was going to try and fit the logic into this somehow, but then I decided to make it a separate script. At first, I was like, okay, do I want to make it a separate script? Like it seems a little silly to try and create a separate script out of or put that small bit of functionality into a separate script. But then I was like, okay, it's best if I do make it a separate script because the way that I'm building this pipeline is certain things, certain steps are going to be optional. In my case, I'm definitely doing them. However, they are optional if you don't want to do them. For example, give me a second. Yeah. For example, okay, in pre-processing, we have batch audio extract. That's a separate that's a separate stage. That's where the audio is extracted from all of the video files. Okay, cool. Then we have batch audio transcribe. This is where all of the audio files are read, so we are not using the video at that point anymore. Mainly we are using at least for this stage, mainly we are using the audio files. So all of the audio files are read and they're fed into an ASR model, in our case, distill small en. They're fed into an ASR model one by one, and transcripts are generated and written to JSON files. So now we have a set of JSON files. After that, we run the next stage, which is batch generate metadata. This is where we generate metadata files for each of the VODs. The metadata files will mainly be generated. I'm trying to remember. Yeah, they're mainly generated using the transcript. So what's going to happen is the transcript is going to be fed into a language model. Uh, I still have to decide what that entire flow is going to be like because I haven't designed that stage yet. There's a bit of testing that I have to do before I can, properly design that stage. We'll get to that point as well. But yeah, wait, hold on. Let me open up my stream on my phone so I can look at the chat. Give me a second here. Okay. All right. So, what was I saying? Yeah. The transcripts that have been generated, each of those transcripts is going to be fed into a language model. And through that, um, we are then gonna generate a VOD title, a VOD summary, and some tags that I can use when uploading the VOD. So there's going to be 3 bits of information that are generated: title, summary, and a set of tags. These 3 bits of information make up the metadata for any given VOD. And then this metadata is going to be serialized to JSON and written to a JSON file. And so, like this, for each VOD, we are going to have one metadata file. Okay, now at this point, at this stage, once we have gone past this stage, for each VOD, we'll have, of course, the video file, an audio file, a transcript file, which is a text file or a JSON file. So we'll have a transcript file and a metadata file. We're going to have 4 files for every single VOD. So this is already a bundle, right? But at this point, we still haven't bundled up the data we haven't grouped the data by VOD. So far, they're grouped by type. So we have all of the audio files in one, we have all of the video files in one directory, audio files in one directory, transcript files in one directory, and metadata files in one directory. Each of these are like grouped by type. So what we want to do is we want to generate bundles where the files belonging to a certain VOD, they are grouped in one directory. So if we are looking at, let's say, a VOD for the 3rd of January 2026, we create a directory with that file name. So it's going to be Twitch VOD 0301 2026 as the directory name. And within that directory, we're going to place the video file for that VOD, the audio file that was extracted from that VOD, the transcript that was generated from the audio, and the metadata that was generated holy shit, that was generated from the transcript. So now we have a bundle. This is what we call a bundle. Each VOD is going to have its own separate bundle. And once we are done, oh yeah, by the way, that what I just described, that is what's done by batch build bundles. So I have a separate script for that. That is what actually goes through each of the directories and bunches all of the data together, bundles all of the data together into like separate bundles. Great, awesome. Once we have these bundles, now each VOD is its own separate package. And each VOD, of course, it's a package. It has the video, the audio, the transcript, and the metadata. What I'm going to do is then, in my case, this is specifically, I'm going to be doing this, but like I want to keep this stage optional. In my case, I'm definitely going to be doing this, but I do want to make it optional, just in case, if anyone else is using this content pipeline and they don't want to do this stage, they shouldn't have to, right? What I'm going to do is I'm going to create a separate script called batch update metadata. And what this is going to do is it's going to go through the bundles directory where each VOD is a separate directory. It's going to go through each of the bundles, and for each bundle, it's going to update the title field in the metadata file using data from this kind of a file. This file will be called vodtitles.json, and this is a file in which I'll be manually entering VOD titles. So what I have, I can show it here, I guess. Hold on. I think it's this. Yeah, this is my VOD titles file that I have. Well, this is a different VOD titles file. This is where I usually save the VOD titles. After I'm done streaming, whenever I'm downloading the VODs, then I usually go through the titles for each of them, and I just copy it over here. What was I saying? Yeah, this is the VOD titles file that I have so far. Eventually, what I want to do is I want to have this kind of a file, which is going to have the VOD titles, and then I'm also going to have this kind of a file, which is vodtitles.json. And before I begin, or before I call batch update metadata, I need to make sure that all of the keys within this JSON, within this dictionary that's mentioned here, all of the keys here match all of the VOD bundles that are available. So to sort of visually demonstrate this, if within the bundles directory there are 10 different VOD directories, there's VOD 1, 2, 3, 4, up to all the way up to 10. If there are 10 entries here, for each of these entries, there has to be one entry, one key within vodtitles.json. This is very important because the whole point of batch update metadata is for it to read vodtitles.json and pull out the the appropriate title, which I'll be mentioning here, and then it's going to assign it to the input to the title field of that specific metadata file. And if the keys don't match, then I'm gonna make it so before I run this entire update process, I first perform a check, which I dude, I found a nice, simple, concise way, thanks to Gemini, of doing the check. It was actually here. Hold on. It was in. So this is a good example. We can. Sorry, zoned out. Okay. So I was trying to come up with the logic for making sure that, for each bundle, there is one existing key in the dictionary. And I asked Gemini how to go about doing this. And apparently, there's a method called all, where if even one of the booleans in it, wait, this is expecting, yeah, okay. If even one of the booleans ends up being false, then the entire thing is going to be false. But if all of them are true, then the entire thing is going to be true. I don't know if this is used with anything other than bools, because like I'm using it specifically for bools, but I haven't looked too deep into what all this gets used for. Let's do d equals all true, true, true. Actually, wait, this requires an iterable. Okay, so that's true. And if we make one of them false, okay, let's make the last one false, then it's false. So if all of them are true, it's going to be true. If even one of them ends up being not true, then it returns false. And then we are using this list comprehension method, which I found really fascinating because I've done list comprehensions like something like this, x for x in range 10, and then that's going to generate a list from 1 to 10. or 0 to, well, 0 to 9, because yeah, it 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 starts counting at 0. Um, so I've done list comprehensions like this, but you can add like extra conditions into list comprehensions, and I haven't done that nearly as much. At least in the coding that I've been doing, I haven't done that nearly as much, or maybe I've done it and I just didn't look at it in this way. But this was like really fascinating to me, doing something like a key in B for key in A. So there's like it's kind of checking for everything in, I think for every item in the list, it's checking if there's an if that item exists in the dictionary. And I found that interesting. This one line is all we need. This is the way to check and make sure that every single key in this matches every single key in that, or every single item in this list matches every single key in that dictionary. Um, and yeah, that's our hold on. Where here? Okay, so that's going to be our logic. That's what I'm going to be following. The first thing I want to do, so I decided to name this step batch update metadata rather than batch update titles, because we are updating the metadata file, and within the metadata file there are 3 fields. So I was like, okay, instead of limiting it to just um, I don't know why each time I have to say the word title, I keep thinking of the word input. For some reason, input is what comes to my mind like immediately. Anyways, so what was I saying? Yeah, I wanted to make it so um, this this script can be used for multiple purposes. So at some point in time later, if I decide to set tags manually, then I can do that if I want. If I decide to set if I decide to change the summary for some reason, update the summary in some way, I can do that if I want. And then I would just need to create a function like I've done here, update title, and then call the function. And I've divided all of this stuff into multiple steps. We still have more steps to go, by the way. Hold on. So this is so far the pre-processing stage, right? I believe after this point we are done with pre-processing, and then we start the actual, I don't know, analysis. Yeah, then we can start the actual analysis stage. Oh, also, I can I can make the upload a part of this, but that would be optional, definitely. Um, upload, upload, upload VOD. Wait, this is interesting. Why is there an extra like symbol there? I'm not sure what that symbol is. Hold on, I need to read this. Frogmouth, read me. Okay, that's not showing up here. Okay. All right. Give me a second. Yeah. So, optional, we're gonna have upload. Why is there a different color for this? I'm confused about that. Okay, what if I add to do? Okay. Oh, I think the reason was because there was a list item that was empty. There was no list, so maybe that was its way of letting me know. But then would that be the case here as well? Oh, okay, okay. Yeah, this is just this is it letting me know that yeah. Okay, that's fine. So we'll give this to do and this one to do as well. So upload VOD is going to be optional, and then analysis is necessary because that's what we have to use for the clipping thing, right? So there's going to be a whole bunch of like analysis that we have to do there. And dude, I'm actually considering using a language model for that purpose as well. So we're still gonna, to be clear, we're still gonna do these things because these are specific tasks: text classification, zero shot classification, token classification, sentence similarity. What else was there? Sentence similarity, summarization, and text ranking. These 6 tasks are, I believe, they are necessary. And there's going to be a bunch of other creative stuff that I'll have to come up with, or there's going to be a bunch of analytical stuff that a bunch of other analytical information I'll have to extract from the transcript. However, instead of using, so previously I was planning on using a mix of transformer-based specialized NLP models, transformer-based NLP models specialized for specific each of these specific NLP tasks. But now I'm thinking of, oh wait, no, let me finish what I was about to say before. Previously, I was planning on using a mix of transformer-based NLP models specialized for each of these specific tasks and legacy NLP methods. I was planning on using a mix of these two. But now, after talking to Gemini about this, when Gemini mentioned that a lot of the language models are able to do this, like just by default, they're able to do it because of the massive amounts of data that they've been trained on. So you can tell them to do exactly this, and they will probably do it like really really well. They'll give you a good, they'll give you a pretty decent, if not better. I don't know about better. I'll have to do some research on that because I was still kind of like torn between using specialized transformer based NLP models versus straight up just using an LLM for all of those NLP tasks. I'm still kind of torn between them, but the research that I've done so far is telling me that apparently large language models would perform these tasks incredibly well, if not better, because they've been trained on a massive amount of data. And according to Gemini, apparently large language models would give you a less robotic response because of the wide amounts of data that they've been trained on. You'll get a less robotic response than using one of the specialized NLP models. Though, with a large language model, the only issue that I would have is, and this issue is going to be mitigated using the outlines library. So if I, well, once I, not if, because I'm going to be doing it, but like once I manage to move forward with learning outlines, and once I get comfortable with using outlines, I'll be able to get an LLM to give me a very specific, a very structured response, as opposed to, a response with a bunch of fluff that LLMs usually tack on. And further from that point, it'll be more about telling the LLM or giving the LLM a specific type of prompt and saying that, hey, analyze this text and extract so and so information for me. I again, I still need to check if, oh, you know what? Okay, I can do something here. I will open up I'm gonna open up a, well, I have opened up a new Gemini instance, and I'm just gonna ask the question here. Hey, so I'm planning on working on a project that's gonna involve analyzing the transcript of a 2 hour long Twitch VOD, and then extracting, or well, and then applying various NLP methods to extract useful info from it and determine which sections of the VOD are clippable. I'm gonna be using multiple different NLP tasks to accomplish this. I'm aware, well, let me also mention, um, using multiple different NLP tasks to accomplish this. I plan on using HF transformers to load the models. So the models will be from HF Hub. I'm aware that there are specialized I'm aware that there are specialized models for various NLP tasks, but what I'm wondering is that would I be able to accomplish those same tasks using an LLM instead? Would the output be better or worse? What would the quality of one versus the other be like, and so on? Okay, analyzing a 2 hour VOD transcript is a classic big NLP problem. You're essentially choosing between a Swiss Army knife, which is an LLM, and a toolbox, which is specialized models. For your specific goal, finding clippable moments, the answer isn't just about which is better, but which is more contextually aware. LLMs versus specialized models, the comparison. While you can use an LLM for every task, the trade offs in quality, cost, and clippability detection are significant. Okay. Specialized. Okay, primary strength. For specialized models, um, the primary strength, the primary strength is precision on narrow tasks, example, sentiment, and with large language models, it's nuance, reasoning, and vibe detection. Okay, then context window for specialized models is limited. usually 512 tokens. And for large language models, it's massive, 32K to 1 million plus tokens. Okay. Then for specialized models, the output type is discrete labels slash scores. And for large language models, it's natural language saying this part was funny. Okay, so that specific thing I'm gonna need to tell it that, okay, give me only these specific labels. Yeah, yeah, okay. So we're gonna have to, I guess that falls under prompt engineering, doesn't it? Like I'm gonna have to give it a prompt that's made in a very specific way that uses specific language and gives it proper instructions. Okay, then speed. Specialized models are fast and cheap. They can run on the CPU and on small GPUs, and large language models would be slower and costly. They need high-end VRAM. True, and that's why I'm using the cloud for my specific situation. That is also why I've divided up my pipeline into multiple stages. Each of these stages, if need be, they can be executed on or they can be run on the cloud. You would definitely need to move the data to the cloud as well. So, for example, I extract the audio from the video in, I extract the audio from the video locally on my PC because that just uses FFmpeg and it's not doing, well, no, it is doing transcoding, but even that transcoding is not that heavy. So I'm able to uh, run it for even for 30 VODs. I'm able to run the extraction process and get 30 WAV files. However, trying to run ASR, automatic speech recognition, on all those 30 audio files, it's not going to be feasible on my local machine. I can't even run ASR on a single audio file because it's an incredibly heavy load, and then my fans start getting loud because the CPU is heating up and all of that stuff. And there's also the fact that there's no GPU available on my local machine where I'm running it, so it's all going to be CPU inference. Whereas if I move this stage, the ASR stage, which is the transcription stage, if I move this stage over to something like Kaggle, and then I upload all of the all of the audio files into a Kaggle dataset, I can then run the entire transcription process on Kaggle and have it produce the output, the JSON output, and store it into a file. And then I can package up, not store it into one file, store it into multiple files. And then I can package up those files into a zip file and download that. So that way I'm able to offload that entire load onto the cloud. So I could use Kaggle, I could use Google Colab. At some point later, I'm going to try and fit this pipeline into into a Hugging Face space. I'll have to see how to go about doing that. I don't think I want to allow for, because okay, a Hugging Face space by default, the free in a free Hugging Face space, you have up to 1 GB of memory. I think it's persistent memory. Words. I think it's persistent memory. I don't think it goes away after you've refreshed the page or restarted the space or whatever. I think so. I don't remember exactly, but there is a thing where you can store a file. I have actually done that. Yeah, yeah. No, there is a thing. You can store up to 1 GB, and then further from that, like if you want to store more than that in the space, then you're gonna have to pay for that space. And that makes sense, right? Because like you get a certain amount for free, and anything more than that, you have to pay. So the idea is, I'll make this pipeline and I'll make it so people can feed in a bunch of audio files. So they have to run the extraction process themselves. The audio, sorry, give me a second. Damn. I don't know. I don't know what happened there. Okay. Um, what was I saying? Yeah, they can run the audio extraction process locally, and once they've produced a batch of audio files, they can then upload this batch of audio files to the Hugging Face space, and then they'll run the entire pipeline in multiple stages where it first runs ASR on each of these VODs, no, each of these audio files, and generates a transcript. It then saves the transcript and probably packages it up as well. I'll have to see how to. I might need to change the code up a little bit to fit it into the Hugging. Actually, I'll have to design the entire Hugging Face space code, and then fit in my logic into it. I can't just like do a copy paste kind of thing like how I'm doing on Kaggle, where I just copy this code that I've written here directly into a code cell and the entire thing executes. It's not going to work out like that on Hugging Face Space because there I have to also set up UI. So I have to make, the entire workflow fit in with the UI. Okay, so we will hold on. How are we going about, because if I'm gonna do this, I don't think we'll be able to set up that whole bundles thing. I don't think that's gonna work out. Oh, something I could do is I could, no, I don't think that's gonna work out. I'll have to make the pipeline specifically for content generation. So rather than doing this whole upload thing, because like in the HF space, I'm not going to be adding in the upload code. So bundling the thing up it's not going to be very useful. And the bundling thing, if I'm being honest, it was specifically for my purpose because I have to store these VODs somewhere. And because I'm generating a whole bunch of data pertaining to each VOD, like there's first of all the audio, then there's a transcript, and then I have to store like the titles, and also there's like a bunch of different data pertaining to each VOD. So it made sense to like bundle it up. Sorry, zoned out. Okay, so it made sense to bundle it up. Words, it made sense to bundle it up. That is why I set up all of these stages. But if I'm going to set this up on Hugging Face Space, which I do want to do that, I definitely want to do that because I want others to be able to use this directly from HF spaces. Yeah, directly from HF spaces, and maybe people could like clone the space and like have their own version of it. Actually, they would need to. Yeah, yeah. Now that I think about it, they would need to clone the space. They would. Yeah, yeah. They would need to clone the space, or I think there's an upload thing, isn't there? There is. You don't need to have persistent storage. Oh, wait, no, you need to have persistent storage because the upload thing that Streamlit allows. Am I using Streamlit or Grady? I think I'm using Streamlit. Yeah, the upload thing that Streamlit allows, I think there's a limit to it. I think it's like a 50 MB limit. So you would need to have like persistent storage. That's a small hurdle. That's not really that big a deal. Um, I could make it. I could like give the user a choice. I could allow them to choose between a single upload and multiple. Yeah, how do I go about doing this? Hold on. Let me open up a new conversation with Gemini. Um, hey, I'm planning on working on a sort of auto clipping pipeline, auto clipper pipeline that I plan to that I plan to set up on uh, Hugging Face Spaces. The idea is the user uploads the audio, uploads a batch of audio files, um, which are audio files containing audio from um, a 2 hour. Well, no, it's hold on. I need to. The idea is, uh, the idea is, the user has, let's say, 5 2 hour Twitch VODs. User extracts the audio from the VODs as PCM. Oh God. Okay. Yeah. There's that too. I did not think about that. Yes. When I extract the audio has to be in a specific format. The audio has to be PCM 16-bit, um, signed, signed 16-bit, little endian, 16 kilohertz wave, mono. All of these things have to be true for that uh, audio file. And in my case, I'm using FFmpeg to do that. I mean, I can provide that code snippet so people can run it if they need to. But yeah, I don't know how many people are gonna be able to do that. Oh, you know what I could do? I could add in a check to analyze the audio and let the user know that, hey, the audio you have provided is in so and so format, but the audio that we require is so and so format, so we cannot proceed further. Use a free tool like FFmpeg or something to transcode the audio, and then you can feed it back in. But okay, back to this question. Um, as PCM 16 SLE, um, PCM 16 SLE, 16 kilohertz mono wave. Okay, user extracts the audio from the VODs as so and so, leaving them with 5 audio files or 5 wave files. User then uploads these 5 wave files to. Should I make it a batch thing or should I make it like single, like for a single VOD you are. Maybe if I made it a single VOD, that would be okay. Okay, no, I can look into that later. For now, I want to see if even just that one VOD file is able to be processed. Give me a second. User then uploads these 5 wave files to the HF space. where transcripts are generated out of them, and then various NLP tasks are performed on them to determine clippable moments. My question is, how do I go about setting up the upload stage? I know Streamlit, which I plan to use, has an upload widget, but I don't know what the limit is there. I also don't know if it accepts multiple files. Another option is to use the HF Spaces persistent storage, meaning the user would have to clone the space and then upload the audio files to their storage, and then the space would read the audio out of the storage. What info can you give to help me out here? Okay, building an auto clipper pipeline for high volume audio on Hugging Face spaces is a smart project, but you're right to be cautious about the upload stage. Handling multiple 2-hour VODs, even as 16 kilohertz mono wave files, can easily push the limits of standard web widgets. Here's a breakdown of your options and the technical gotchas for each. Using Streamlit's st.file uploader. This is the easiest path, but it has strict defaults. Multiple files, yes, it supports them. You can set accept multiple files to true. The default limit is 200 MB. A 2-hour 16 kilohertz mono PCM16 wave file is approximately 115 MB. 5 of these would total 575 MB. The fix, you must increase the limit in a .streamlit config file in your repo. I didn't know you could do that. I did not know you could do that. Enable XSRF protection. This is highly recommended for HF spaces to prevent upload 403 errors. Okay, the risk: Streamlit stores uploaded files in RAM by default. If you upload 5 large files at once, your HF space, which has 16 GB RAM on the free tier, might crash because you also have a large Whisper model loaded. Okay, it's assuming I'm going to be using Whisper. I should probably mention that I'm using Distill Small EN. And dude, I'm so glad that I found out about, well, thanks to Gemini, I found out about Distill Small EN, because holy shit, it is so much smaller compared to Whisper. I haven't even run Whisper, but the amount of times Gemini has told me that if you're running Whisper, then it's going to be taking up a lot of RAM. That tells me, and the fact that when I actually run Distill Small EN on a Hugging Face notebook, the RAM usage doesn't usually cross more than just a couple GB. And I'm talking like 2 GB, maybe 3 GB, maybe. And also, because it's using the GPU, so it does offload some of that to the GPU's VRAM. So even in the VRAM, there's like maybe 2 or 3 GB being used. It's dude, I'm so glad that I found out about Distill Small EN. Okay, where was I? Yeah, using persistent storage, the quote unquote pro way. Hugging Face offers persistent storage, usually 20 GB plus for free on certain tiers or via request. This is better for long term projects, but the uploading part is different. How it works, it, you don't clone and upload to it like a Git repo. Instead, you use the Hugging Face Hub Python library within your app to save files to the data directory, which is where persistent storage is mounted. Better alternative, instead of the user cloning the space, you can have a manager script or a simple Python script on the user's local machine that uses api.upload file. Okay, wait. This is assuming that they're going to be using my space through like a as in not through the web UI. I was aiming for the web UI, not for making it like API friendly, I guess is the best way to put it. Anyways, to push the VOD to a private HF dataset, your space then simply reads from that dataset. Benefit, this offloads the heavy lifting from the Streamlit UI to a stable API connection. I like that first idea. I like that first idea because that's going to be a lot simpler and it makes it so. Wait. Okay, so I should have mentioned that I plan on letting the users use the space through the web UI, which is why I'm using Streamlit. I wasn't really aiming for them to be able to use it through through the API. I'm giving more importance to, though, okay, now that I think about it, at some point later, I could probably change things up and also make it, or maybe I could make a different version that does end up being, give me a second, that does end up being API friendly. So it allows people to use the space through API calls rather than having to, get into the web UI. I'm giving more importance to the web UI for now, though an API friendly version could be on the roadmap. Later on. I did not know that I could increase the limit on the file upload widget. I'm definitely gonna try that. I also plan on using Distill Small EN, not Whisper. The former tends to be a lot smaller and lighter than Whisper, apparently. Okay, that's a solid choice. Using Distill Small EN is a massive optimization. It's significantly faster and lighter than the base Whisper model, which gives you more breathing room with your RAM. Since you're sticking to the web UI, here's exactly how to handle those large file uploads without crashing the space. The configuration must have. To allow files larger than 200 MB, you need to create a folder named Streamlit so-and-so at the root of your repo and add a config.toml file inside it. Note, on Hugging Face, you should also disable CORS and XSRF protection for the uploader to work reliably behind their proxy. I'll have to look into what each of those are. Um, XSRF is some kind of attack from what I remember. I don't know what CORS is. Hold on. XSRF. Wait, cross-site reference something, isn't it? XSRF attack. Cross-site request forgery. XSRF. Okay. Okay. Is a web security vulnerability. This is why it seemed familiar, because this I had read up on this like more than a decade ago, back when I was trying to learn what was it called? I think it was just called SQL injection. Yeah, this was one of the multiple things, including SQL injection, that I was learning back when I was really interested in like web pen testing. But yeah, okay. Anyways, continuing. The clippable challenge. A Twitch clip is rarely clippable just because someone said a specific word. It's clippable because of a buildup of energy or a sudden shift in tone. Specialized models are great for scanning the whole 2 hour VOD for specific entity mentions or toxicity. LLMs are far superior at understanding why a 30-second window is a highlight. They can recognize sarcasm, fail moments, or clutch plays that a standard sentiment. Am I looking at the right thing? No, I'm. Hold on. It was a different. Okay, I was looking at the wrong Gemini conversation. Okay, memory management strategy. Streamlit's file uploader keeps the uploaded data in RAM. If the user uploads 5 files at 115 MB each, that's 600 MB of RAM gone immediately. If you then load a model into, oh wait, the space is not going to have free GPU. Though what I could do, I could try, and I don't know how well this is going to work out, but I could try and contact Hugging Face and request GPU, because this is essentially a community tool that I'm building. So I could like request free GPU, and they could enable free GPU. And yeah, I don't know why they would do it though, because like what I'm doing is, sure, it's going to help the community, but like it's not helping AI research necessarily. It is using AI tools in creative ways, because like, of course, transcription and then various NLP tasks to understand that entire transcript and stuff like that. I don't know if they're going to find that really valuable, or valuable enough to give me free GPU. Valuable enough to give me free GPU. I sure as hell am not going to be paying for GPU for other people to use. I'm not even paying for myself to use, because I don't have the money for that. Though it's not expensive on Hugging Face. Let me put that out there as well. They have like a decent, pricing model, and it's like they charge you by how much you use. So it's not like, you pay and then it's getting wasted. But yeah, anyways, I can look into that later on. For now, I'm running this locally. I haven't even set up the Hugging Face Space version of it yet. For now, I'm not running it entirely locally. For now, I'm using it for my purpose. The next step after the entire pipeline is ready is to upload it to GitHub, and then depending on how well this works out for me, I could set up the Hugging Face spaces, or the Hugging Face space version of it, because yeah, I'm gonna be using the same logic. It's not gonna be all that different in terms of the logic that is required. Maybe there might be minor tweaks that I have to do here and there. I'll have to handle paths as well, make sure that it's able to read input from the right path and give input to the right path, and then the next stage is able to read input from the right path and give output to the right path, and so on. Um, Sorry, zoned out. But yeah, yeah. Let's just finish reading this and then I can continue with my update metadata script. Okay. If you then load a model into RAM, you might hit the 16 GB limit faster than you think if multiple users are. Oh God. Okay. I didn't think about that. No, I didn't think about that. Hold on, dude. Okay, ephemeral storage. Files saved to a local folder like temp audio above will be deleted every time the space sleeps or restarts. This is fine if you process the clips and let the user download the results in one session. That is the plan, actually. Let the user download the results. The results are going to be JSON. The results are going to be like one big JSON file, and then I can write a separate tool that people can run locally. But even that is going to be a multi-stage process. Now that I'm thinking about it, that's going to be a multi-stage process because people are going to have to extract their VOD audio locally and then feed the VOD audio into the space. And then the whole, pipeline will run and it's going to spit out timestamps for clips in each VOD. And I can make that as one big JSON file. That's fine. But no, I didn't think about, wait, that's crazy. A significant correction, cloning the space. You mentioned users might need to clone the space and upload to the storage. Avoid this workflow. It creates a huge barrier to entry for the users. With the config, oh, you know what? That's true. Cloning the space means people would need to have a Hugging Face model. No, not model. A Hugging Face account. And that's not going to make things the simplest. Okay. Wait, you mentioned that the 16 GB of RAM is going to be shared amongst all the users. Wait, I spelled amongst wrong. Amongst all the users um, using the space. Yes, exactly. One Hugging Face free tier. No, on the Hugging Face free tier, the CPU basic hardware, you aren't getting 16 GB of RAM per visitor. You're getting one container with 16 GB of RAM that hosts the entire application for everyone. Think of it like a small kitchen. If five people try to cook five different massive meals at the exact same time, the kitchen will run out of counter space and crash. The reality of multi-user RAM. If you are if you use the standard st.file uploader, here's how the 16 GB gets eaten up. The model, distill small en, is small, 500 MB, but once loaded into RAM with its dependencies such as torch and transformers, it might sit at 1 to 2 GB. User A uploads so and so, user B uploads so and so. processing while transcribing, Python creates temporary buffers. If you have 10 concurrent users doing this, you'll hit that 16 GB limit, and Hugging Face will automatically restart your space, kicking everyone off. How to protect your space? To make this work for multiple users on a single 16 GB instance, you need to move the data out of RAM and onto disk immediately. Use the disk. It's 50 GB and free. Every free space comes with 50 GB of ephemeral disk space. While the disk is wiped if the space restarts, it is free memory you can use during a session. Okay, back up. Wait, so this has me a bit concerned about one user having access to another user's data. Is each user's session containerized in some way? Is the containerization applied? What am I trying to ask here? Is there a system? Okay, is there? Oh wait, if there are containers for each session, is it that there's a system? This is all like cloud infrastructure questions that I'm asking, and I don't know jack shit about cloud infrastructure, so this is good to learn. Is it that there's a system in place that's sort of distributing resources amongst containers until the max usage is hit? That is a great intuition to have. When you're building a web page that handles user-generated content, security and crosstalk are the biggest concerns. The short answer is no, the users are not containerized individually. Hugging Face, oh wait, okay. Hugging Face spaces use a single container architecture. This means user A and user B are essentially roommates in the same, oh God. Okay, how resource distribution works. Well, okay, no, hold up. I was concerned that users would be able to see each other's. No, that's still a possibility, right? Because that if if multiple people are using the ephemeral storage, and if I've kept similar file names, then won't they be like rewriting each other's files? I think I'll have to come up with like some strategy for naming the thing based on different users, and then we can have like different files. And because there's no custom Python code being put in there, so users can't really read other people's stuff. Okay, how resource distribution works. Because it's one container, there is no system automatically distributing resources between users. It's first come and first served, free for all. CPU. If user A starts a heavy transcription, the two vCPUs will hit 100%. If user B clicks process at the same time, the CPU will split its time between them, and both users will see progress bars crawl at half speed. Okay, RAM. This is the hard limit. If user A fills 10 GB and user B tries to fill 7 GB, the entire container crashes for everyone. Okay, the system just sees memory over limit. Okay, this is going to be a little more complicated than I thought, because yeah, this is going to be a little more complicated than I thought. I'll have to figure out like a multi-user kind of thing. This is assuming that multiple people even use the thing that I'm building. It could just end up being one of those things where people will use it for maybe, you know, one or two tries or three tries or whatever, and then they're good to go. Mostly if people are um, mostly if people are streaming and they have like an active audience, then they would be expecting the audience to clip stuff for them. So many people probably won't be using this. I could be completely wrong about that as well. Maybe people, maybe even like, you know, bigger streamers might want clips at a higher rate than what they're currently getting. And maybe they would like some sort of automated pipeline to do that. You never know. Okay. The data privacy risk, crosstalk. Since everyone shares the same disk, you have to be very careful. If you just tell your app to save files to a folder called uploads, and user A and user B both upload a file named, this is what I was talking about, both upload a file named myvod.wave, user B might accidentally overwrite user A's file, or worse, your script might process user A's audio and show the result. That's crazy. Okay, show the results to user B. How to create pseudo isolation. You can solve this in your code by creating unique slots, unique silos for each visitor using Streamlit's session state. A generate a session ID, each browser tab. Okay, okay. All right. You know what? Yeah, I've done this before. Streamlit does have certain, it has like a lot of state-based things where you can like set states for uh, various variables. And this is how you can like persist states between UI changes and stuff. So that's probably one of the things that I could use. However, that being said, yeah, this is going to be a little more complicated than I thought. So for the time being, I'm going to stick to my local thing that I was initially working on and still am working on. And we'll look into the Hugging Face space thing later on. Okay, now I was supposed to be working on batch update metadata. So the first thing we're going to do is check, actually not in here, we're supposed to check in here. Also, so we're going to be looking into the bundles directory, right? Yes. So VOD titles path has to be in here because it's needed by update title. It's not needed by other functions. If I ever make functions later on, it's, yeah. Wait, what? That's interesting. It purposely adds it makes sure that there's two lines here when I save the thing. Something to do with formatting. Okay, so we have this. We want to read. Okay, let's create VOD titles data equals this, and then we're gonna do open VOD. Where is this being run? Oh yeah, okay. So oh, I have VOD titles path. Yeah, yeah. VOD titles path. What does this require? Does this accept just a path? Oh yeah, okay. File descriptor or path, and path is part of the standard library, so we are good. So we want to read, and then we want to store the data into this. Oh, as fr. VOD titles data equals fr dot loads. No, JSON dot load, and then we pass fr, and I don't think we need to pass any indentation related stuff. I do need to update the dummy script. I should actually move that. I should actually move that into something, into like a proper like debug script thing. Oh, I could name it debug underscore create dummy script or something like that. Let's do that. Let's do that real quick. Um, dbg create dummy data dot py, and then we copy this entire thing. Is there anything up here? No. Yeah, we copy this entire thing. I think I can get rid of that. I think I can get rid of that last part because I don't need to worry about that too much. I do need to worry about that. Hold on. Now I don't need to worry about it. Create project files. In here, there is something I need to do. I need to check. This is actually very clever. The way I actually got this idea from Gemini. Like anytime I need to do multiple folders based things, and if there's a specific pattern being followed, then I can probably use something like dictionaries. And the reason for that is because you can then iterate over each of the keys of the dictionary using, well, dictionary.items, and that returns a tuple. The tuple contains the key and the value. So in this case, it's the folder and the extension, which you can see is up here. And yeah, the extension also includes extra stuff. So this is great. This is very clever because what I needed, I had like a fixed pattern being followed. So if the VOD is called VOD01, then we're going to have, the video is going to be VOD01.mp4. The audio is going to be VOD01 underscore audio dot wave. So that's being added here. The transcript is going to be VOD01 underscore audio underscore text dot JSON. So that pattern is here. Honestly, this could have been underscore transcript. I could have done it like that, but this is sort of a how do I put this? This naming convention is from back when I didn't know all of the stuff that I know now about, you know, all of this path related stuff. And this is from like, this is basically legacy. It's going to remain in this ugly form for legacy reasons. And that's fine because audio underscore text, yeah, that does kind of say that, yeah, this is a transcript. This is a text version of the audio. So I'm just going to leave it like that. One of, dude, again, it's legacy reasons, but one of the biggest reasons I'm going to give for that is that I already have 30 VODs, not even well, yeah, around 30, because this month I have had maybe 2 or 3 streams where I had to like split up the stream into multiple streams. And so if we are counting from the 3rd of Jan, which is when I started streaming this year, like the first stream of this year, if we are counting from there up to the 31st, that would be 28 streams, right? But then if we count 2 or 3 of those days as having 2 streams each, then easily the count goes to 30 or 32 or something like that. So anyways, I already have around 30 VODs that have been transcribed, and I don't want to redo it. Just being honest, I don't want to redo it because I'm gonna have to re-upload the entire audio, all of the audio files. I'm gonna have to upload them to the Hugging Face dataset again, and then run the transcription again. And because it's 30 whole files, so that's gonna take a good couple of hours to finish, and that seems kind of unnecessary. However, I am still very early in the stage in the pipeline stages. I am still very early in the development of this pipeline. So if I do that, if I do that, um, I would be able to change audio underscore text to transcript.json. And then it can just be called transcript. Then I could also change the directory name to transcript. I would have to go into each directory or I would have to go into each script and make sure that wherever it's supposed to be looking for text, it's instead looking for data slash transcript instead. Yeah, yeah. I would have to do that. I could just change it to audio. I could just change it to underscore text. There was another actually, yeah, there was one more thing. There was a specific, like, it didn't occur to me to um get rid of, certain portion of the text, certain portion of the string before. It didn't occur to me to do that. So, where I think in build bundle, that might be a good example of that. Is there? No. Metadata, audio transcribe. Which one was it? I don't think it's under build bundle. Batch generate metadata. Oh, I think. Oh, yeah, here's an example. This is one of the things that I didn't know about. Like, I could use remove suffix and remove prefix. So if I would have done that before, I could have very easily um, set up like whatever, suffixes I wanted. But instead, what I ended up doing is just tacking on a new suffix onto the string. So if it was so um, VOD01 would then become VOD01 underscore audio. That's from FFmpeg, and that's fine. Though even in FFmpeg, I mean, FFmpeg, to be fair, is being launched from Python. So even there, I could have like changed the name. Though, I mean, this is how it's supposed to be. It's supposed to be underscore audio. We have VOD01 and then VOD01 underscore audio. But then I feed VOD01 underscore audio into the ASR script and through the ASR model. And the name that I choose is VOD01 underscore audio, which is the already existing name. And then I just add a suffix, which is underscore text. Instead, what I should have done is remove underscore audio and then instead put in underscore text, and that would have solved the problem. But I didn't know about that before. You know what? I mean, at this point in time, I could redo that entire process. In a way, it would be good because it would give me a chance to test out my entire pipeline, and I could just delete the old data that I have. I've been storing the old VODs. Um, yeah, yeah. Okay, what was I doing? I was here. So we read. Apparently, I did not import JSON. So import JSON. All right. So we store the data in there, and then um, check if all um, if all bundles, check if each bundle has a corresponding key in VOD titles.json. or in VOD titles, VOD underscore titles. Yeah, in VOD underscore titles underscore data. Oh, we could just return out of the function, right? If yeah, so we could have a key mismatch thing and then just return out of. So we could do try. That's not going to raise an exception though. I don't need to do try. Give me a second here. Okay. So, yeah, let's say keys underscore match. Keys underscore match equals. So we have a dictionary from here. We should have. How are we comparing? I could pull out the name. Yeah, I would have to change this a little bit, right? Bundles directory dot glob. I need to make sure that it's just the I need to make sure that it's just the directories that are being read. Okay, what are we trying to do here? We are reading from the list first. Okay, let's do something here. So all X for wait, I feel like I should prototype this somewhere else. Yeah. Um so we have a list here. Okay, if we do this list, um um hold on. What do we okay, let's try this. Key in or A in A. Does this work? So there's no error. Don't do that. Um True. Key in A. But then where is it getting key from? Okay, so we are returning. Okay, key in A for key in. No, hold on, dude. Uh, Wait, let's try doing a list comprehension here. Yeah, let's do key in A. Does this work? This is not going to work because it's not defined. Key for key in A. Is that going to work? That's going to work. This is going to read everything. So A is our list. A is in iterable, so it's going to iterate over every item in A, and so it's just going to give us ABC. So that's our list comprehension, right? But then we are doing this here. Oh, what if I do this? So key in, so this would then, I think, return Booleans, right? This returns Booleans. And then based on that, we are doing that. Okay. Man, this is still, so this is essentially, well, no, not exactly. I was about to say that this is essentially Boolean indexing, but no, it's It's a little different. It does return a Boolean index, but like you're not really using it as a Boolean index. Um, okay. What was I gonna do? Yeah, I need to, dude, I need to play around with this because I'm using this thing, and it's kind of interesting because you are able to pass in this thing like this over here. Do I need this here if I, okay. What if I do F equals key in B for key in A? Does that work? No, that requires list comprehension. This doesn't require, well, that requires the, I mean, the square brackets. This, however, doesn't require the square brackets, and I'm also able to pass it in here. I need to look into how that is working exactly because this is, am I passing in, am I still using list comprehension, or is something else being passed in here? Because when I had a conversation with Gemini about this, which I haven't completely finished reading until now, but when I had a conversation with Gemini about this, it mentioned something about generators, generator methods, or something, or generator expressions, I think. Yeah, I haven't fully finished reading that. Give me a second. Um, I have way too many tabs open here. Right, so in here, what I'm trying to find, okay, key in the dictionary. We have the dictionary. We have the dictionary, but we need, okay, bundle does list equals, um, I need just the names. I need just the names. I don't need the paths. So, you know what we could do? Wait, it would be key dot item. Yeah, it would be key dot item in bundles dir dot glob for key in VOD titles data. And then I need to see what that returns. Actually, I need to, wait. Let's copy this and go to the next line. Just a second. I don't know what's in my copy buffer. So real quick, just going to do something. Yeah, it's a good thing I did that. Hold on. Oh, right. Um, okay. Yeah. Back to this. Yank and paste. It does that. Okay. Then let's yank and paste it here, but I need it to be something like this. Yeah, let's just do temp equals this and then print out temp. Let's see if this. Yeah, I think I can I think I can just run this entire thing. Um, there seems to be an error. Update title. Okay. Going back, load decoder error. Oh, it mentioned a trailing comma. Wait, I think I know what it's talking about. It mentioned a trailing comma. I think maybe JSON doesn't like trailing commas. Let's try it now. Now we seem to have another error. It's not key.item. What was it? It wasn't key.item. What? Wait, was it key. No, it wasn't key.item. What was that thing called? I forgot. I forgot what it's called. Hold on. Let's go into one of the other scripts here. This is item stem. That's what it's called. What is this change that I made that requires me to save something here? Oh, that's the change. Um, right. So, stem. That's what I'm looking for. Stem gives you just the file or directory name. I hope it gives you directory names as well. Did it not save? Oh, yeah. What's the issue now, dude? No attribute stem? Okay, I think the issue is that I don't fully understand that expression, and so I'm just making guesses here. So let's do temp list equals um, key dot stem for key in bundles dir dot glob so and so. Let's make sure that we have this. Okay, that works. So now that we have this, oh God, what did I just do? Let's not do that. Okay. Um, all right, key in. So now we have a list here as well, don't we? Yep. Key in temp list for so and so, and yes, okay, that's done. Temporarily, let's change this to 11 and then see if it works. No, last one is false. So we know that our logic works. And yeah, I can just change this now. Let's say bundle, let's say bundles list, and call this keys match, keys underscore match, key in bundles list, and this has to be fed into all. And then let's read keys match true. Let's test that out again. False. Great. So we know that that works. Okay. So So now here I can add a check that if not keys match, print key mismatch, aborting operation. Otherwise, we let the entire thing continue. So let's also test this out. Let me just make sure that my logic there is working. Key mismatch, aborting operation. Oh God. What just happened? Just a second. Okay, that was odd. Okay, save this and go back here, and yeah, we're good to go. Wait, here. So if the keys match, then we go over each of these. I don't think we need to check anymore. I mean, I'm still running the check just in case, but like, I feel like it would be redundant at that point, because if there is a file named that, then no, if there's like an extra directory in the bundle, or if there's even a file that they've accidentally placed in the bundle, we're going to get a key mismatch. I can probably make this a little more detailed. Key mismatch, aborting operation. Make sure that for, my God, can I type? Make sure that for every bundle in bundles directory, there is a corresponding, hold on, there is a corresponding key in key, not key, vod titles.json. Okay, great. Right, I don't think we would need this anymore. We can just, so for each bundle, we are then loading so we have the bundle, we load the metadata file. We load the metadata file. So the path would be metadata path equals bundle, which is the path, and then bundle.stem plus see, this is one of the reasons I was saying yesterday that if I vibe code this, I'm not doing nearly as much iterative, development or incremental development, because usually what I'll do is I'll write a chunk of code and then run the thing, test if it works. Then I'll write another chunk of code, run the thing, test if it works, and then like I'm incrementally developing the thing. But if I just get it vibe coded, then all I have to do is check that it matches the logic that I'm trying to implement, and the tiny specifics that are there, like paths, for example, are correct. That's all I have to check, because I know that what Gemini is making is going to be, accurate. Okay, metadata.json. So metadata underscore file path. No, that's fine. Okay, so then we open up the thing. So open Metadata path. Why is that not working? Is there an issue? Wait, is there an error somewhere up here or down here? No, I think we are good. Okay, I'll open it in read mode as fr, and then yeah, let's just say metadata equals json.load fr dot, no, not dot. Okay, so then the entire data is loaded and we'll print the data out. This is going to throw an error. I just realized that because we do not have the correct data in the thing. Okay, what's the issue here? It is not supported for types, path, and literal. Okay, that's a problem. How do I wait, let me ask Gemini. In Python, I have the following expression. Bundle, no, metadata underscore path equals bundle slash bundle dot stem. Wait, yeah, bundle dot stem plus underscore metadata dot json. Bundle is a path. If bundle is vod 01, then within the vod 01 directory, we can expect a vod 01 underscore metadata.json file. I'm trying to read that file. I see what's happening here. It's a classic operator precedence snag. In Python's pathlib, the slash operator used for joining paths has lower precedence than the plus operator. Oh, so the plus is being applied and then it becomes a string. It's not a path anymore. Actually, is the stem, what does stem, what is a, stem is already a string. Stem is all, though, if I did this, let's get rid of this. Now we don't have an error and it's still a path. That's weird. Used for string concatenation. Okay. The issue, because of how Python evaluates expressions, your current code is doing this. It calculates bundle.stem plus so-and-so first, then it tries to join bundle with that string. If bundle is a directory named vod01, the expression evaluates to vod01 slash so-and-so so-and-so. While that looks correct on the surface, it will actually point inside the vod01 directory if your metadata file is sitting next to the directory rather than inside it, or if you want to ensure the path logic is robust, we should tweak the approach. No, I'm trying to look inside. Hold on. Let me mention. I'm getting an error saying, because I think Gemini assumed that I was having some other issue. Let me get the exact thing. Operator plus is not supported for types, path, and literal. Operator plus is not supported for types, path, and literal. I don't understand this because if I remove the literal, then bundle slash bundle dot stem is still um, doing an operation. Oh, it could be that slash is supported, but plus is not supported. That could be an issue. Oh, if hold on. If that's the issue, what if I like group the thing so it does the concatenation first? Oh, that's all. That's crazy, dude. Yes, this is not going to work because we don't have the words. We don't have the um, we don't have the JSON data that we are looking for. So I need to fix my dummy data thing that I made. Okay, in here, construct so-and-so, target directory, file path, this. Okay, if if actually that should come here, I guess, for prefix and file prefixes. So this is running per thing there. No, it should be here. It should be here. Okay, if folder is metadata, is that what we have here? Yes. If folder is metadata, then how do I create multi-line JSON? Oh, no, there's an easier way here. Let's create some dummy, this should go in data. Dummy dummy metadata.json. Okay, and in here we can create the metadata. So title, whatever, and then summary, whatever, and then tags, whatever. So now that that's done, wrong thing there. So now that that's done, I should wait. Let's read this first. Read dummy metadata with open. What is it? /data/dummy metadata.json r as fr. Dummy underscore metadata equals this, and then we'll do dummy underscore metadata equals JSON dot. Do we have JSON up here? We don't have JSON. Wait. Import JSON, and then come down here, JSON.load. Just FR should be enough. Right, so we have our metadata loaded. And now here, if folder is metadata, then that's our exact file path, isn't it? So let's do I have something called metadata so far? Is there? I don't think I have. I don't think I've created anything called metadata in here. Yeah. Metadata equals Um, what am I trying to do? Oh, in this case, it's just supposed to write the data because this is an empty file. It's not supposed to read first. So with open file path, file path write as fw fw dot um, write, I guess. Yeah, fw dot write dummy metadata. And so then that's going to be our nope. Okay, there's a problem. Use so and so to compare literals. Here we probably want to wait. What's the issue? It's not accessible as str. Oh, I have to convert it to JSON. I didn't think about that. Yeah, yeah. Wait, I'll do that real quick. Here we are getting this warning, so let's fix that. And here let's do JSON dot dump dumps, and that should be it. We can also add indents here. Okay, now to run this, or before running this, let me go and delete the bundles and make sure we have nothing here. Okay, let's do debug. Okay, files created, great. Metadata, hell yeah, dude. Okay, so we now have our metadata here. And now we can do batch update metadata. It says key mismatch, aborting operation. So we do have an issue here. What's the issue exactly? Bot titles. No, why is there, hold on, why is there a key mismatch here? Where's the, dummy metadata, okay. We can close this. This is creating perfectly fine, isn't it? Do we have any naming errors here? I don't think so. Yeah, everything there seems to be fine. Oh, we haven't generated the bundles. Um, build bundle. Now we should have the thing. Now that we, yeah, so all of the other data is empty. And if we just look at temp bundles, if we look at temp bundles, what's the directory that I need to stop using temp bundles, dude? Because wait, I should move this script. Yeah, that should be good. Right. This here, we're supposed to be looking for bundles. Nowhere else do we have that mentioned. Okay. And then here also, what did I mention for bundles? I mentioned bundles. So it's still going to find an error if I do run the thing. Yep. What we are going to do is delete all of these bundles. We're going to delete this entire directory. So now first we're going to generate our dummy data. Then we're going to bundle up the data over here, and then batch update. Okay. All right. So our data, we haven't updated the data, right? Batch update metadata. Once it finds the thing, then it's going to print it out. metadata, then we need to have I already loaded up VOD titles data? I've already loaded up VOD titles data. Bundle name, bundle stem. So I should be doing it based on that. So, okay, here's what we're going to do. So this is loading. Okay, but what we're going to print out is, just for the sake of testing, we're going to print out VOD titles data and use bundle.stem, I think. Yeah, use bundle.stem as the key and see if it's printing out the data. It's printing out the data. So we have now loaded this. What we want to do is set metadata. This is a dictionary. So metadata.title equals VOD titles bundle.stem, and then we want to print out metadata. Okay. Oh, I did not take into account that I'm also going to be writing, not just reading. Where do we go from there? Once I've read the data, wait, I need to check. Oh, I forgot I was still having this conversation in Gemini Web. What was Gemini Web gonna suggest? If the file is inside the bundle directory, use parentheses to ensure the path joining happens correctly, or use with name. Oh, okay. Yeah, yeah. It was gonna suggest the same thing that I did already. Okay. What was my question gonna be? Okay. I'm in no in Python. I have opened a JSON file using or opened a JSON file in R mode, but I realized, wait, using R mode and the width block, but I realized that in that same block, I also want to write the data back to the same file after making a tiny change to the dict. Okay, changing a file in read-only mode is like a one-way street. You can look at the scenery, but you can't touch it. Okay. If you try to write so and so, then you'll get an unsupported operation error, non-writable error. Okay. To read and then write to the same file within a single code block, you have two main options: R plus, which is read and write, and then the clean way. While you can do it in one block, it's often safer and more readable to separate the concerns. If the file is small, which most JSON files are, the performance difference is negligible. And this is, well, I mean, this is a one-way operation anyways, or it's a one-off operation anyways. So I don't think the performance is really going to be that much of an issue here. The performance is negligible, and you avoid the risk of file corruption if the script crashes mid-write. I did not think of that. Okay, we can do that. What we could do here is back up there. So what we could do here is just define metadata. And then we do that. Okay. And then once we exit, we open up. Oh yeah, okay, we could remove this and bring it here. Okay, metadata path w as fw, and then we want to we are doing fw.write json.dumps json.dumps metadata indent 4. Okay, I think that should be it, right? So if I do this, it does the writing. And at that point, if I go into one of the metadata files, we have our metadata loaded. Yep. Or we have our metadata updated. I can just add some like extra print statements or something. Yeah, I can actually add print statements for each of these iterations, saying, writing or updating title in so-and-so file, just so there's a bit more verbosity going on. But yeah, with that, our batch update metadata script is complete, and we should be good to go. We should be good to move on to, oh, yeah, you know what? I think I'm gonna change the directory structure. I'll also have to change a bunch of these things, so I'll have to go through all of these scripts. But it's for the best, so I'm not complaining. I'll change up the directory structure so it says instead of underscore audio underscore text dot JSON, it'll just say underscore transcript dot JSON, and then we'll have underscore metadata dot JSON as well. I feel like that'll be a little more cleaner, and I can also change up the directory structure. So I guess this comes under refactoring. I have to go through all of these scripts and make sure that the paths that are being used. Fortunately, I've mentioned the paths, above, except for in which this one, except for here, where I've put VOD titles path there. But that's okay. Yeah, that's fine. It's still visible, and this is not going to be too much of an issue until, if at all, I ever get into, uh, if I ever get to the point where I have to write a function to update the summary and also update the tags and stuff. I don't think that's going to be too much of an issue. Okay. All right. You know what? We could do it right now. We could actually do it right now. So what all are we looking at? This has nothing to do with it. This has nothing to do with it. Audio extraction. Audio extraction, and then okay, that's the, oh, this is audio extraction, right? Output folder is supposed to be Kaggle working. I'm going to change this as well. Kaggle working transcript. And here, because this entire thing, it has to run on, it has to run in the cloud. It has to run in the Kaggle notebook. I have no way of testing this, but I'm just going to hope that this works. So remove suffix underscore audio, and then we add a suffix underscore transcript. Transcription complete. Okay. Okay. That's fine. What is the next step? Oh, wrong thing. What is the next step after that? Batch generate metadata. All right. So we remove, in this case, transcript. Oh, I just realized, yeah, I have a way to test this out because I have my dummy script. Yeah. I can do that. I'm glad that I made this dummy script, dude. This has saved me so much time. Holy shit. Shout out to Gemini. What are we reading? Actually, no, wait, yeah, what are we reading? Oh God, don't do that, don't do that, don't change. Yeah, okay. So we are removing underscore audio underscore text. We are reading, oh yeah, we are reading the transcript file and, oh yes, this is also supposed to be done in the cloud. So I'm going to be testing this out later on, not now. But yeah, this also has to be done in the cloud. I am not done with this script like at all. I haven't. I still have a lot of stuff to do here. I have to write out the entire logic for this. I haven't had the chance to sit down and. Oh, I don't. I also don't have. Wait. Um, let's delete this and create transcript. And here as well. Oh, here, let me just rename this. I actually didn't need to delete that other thing. Why did I delete it? I don't know. Anyways, transcript. Now we are mainly working within this directory, but now when I come here, I should have transcript. Great. Awesome. So then that gets stored into, yeah, it's going to read from transcript and it's going to store into metadata. Then we have the build bundle, which is going to read data. Okay. And then here, instead of text, what is this? Build bundles. Yeah. Instead of text, it's going to read transcript. And instead of underscore audio underscore text, it's going to read underscore transcript. I think everything is fine. Create dummy data. Let's also change the thing here. What just happened? Yeah, okay. Transcript. And then this is also going to be underscore transcript. Underscore transcript. Anything else we need to change? I don't think so. Dude, the amount of changes I've been able to make because this dictionary style format is being used, it is insane. Like this has actually been super helpful. And I only thought about this, or I only learned about this thanks to Gemini. Not about dictionaries themselves, but like I only got the idea of using dictionaries and then iterating over their keys thanks to Gemini. Because in the past I've used dictionaries for things, but not for not in this specific way. Okay, VOD titles. Okay. Our dummy data is also fine. Bundle generation is also fine. This is reading from transcript? Yes, okay. Where does dummy data go? Okay, all right. That's going to create a thing. Okay, great. Batch update metadata. I think we are good here as well. We are not touching transcript here. I think we're good. Yeah. So what we're going to do is go and delete all of these bundles and then run this and then build bundles and then update metadata. We don't have any errors so far. Okay, cool. It works. And we have our transcript folder as well. And even the files are called VOD01 underscore transcript, VOD02 underscore transcript, and so on. Awesome. Hell yeah, dude. We made some crazy progress today. We made some crazy progress. This is insane. This is insane. Now I need to sit down and write uh, the generate metadata, I think. Yeah, I need to sit down and write the generate metadata logic because that's going to involve using an LLM. First, I'm going to have to write down the basic logic. I mean, how is that supposed to work? Because like in my dummy script, we are creating the metadata, like, um, during the dummy data generation process. But I think in batch generate metadata, we will be creating a dictionary. The dictionary is going to be populated with a bunch of data that's going to be, returned by the model each time. And then we finally write that data to a file. That's how that's going to be working. We are not going to be reading from a metadata file because at that point in time, the metadata doesn't really exist. What exists is the transcript. We read the transcript, we join all of the sentence chunks into one big blob of text, and then we feed that into the LLM so it can generate a summary for us. And yeah, it seems like I'm going to have to use an LLM. One of the biggest reasons is the context window, because based on what Gemini is telling me, I still need to do more research on this, but like based on what Gemini is telling me, um, the context window in LLMs is much bigger than the specialized NLP models. I could check it myself though. Each of the models for the specific tasks that I'm trying to accomplish, each of the models I could check and see if like what's the context window size. I could also do like a word count and see how many words on average I have for my VOD transcripts. Yeah, I could do that. I could do that. All right. Okay. Huh. Holy shit, dude. We made some good progress today. We made some crazy progress today. Now give me a second. Okay, that was unfortunate. Yeah, give me a second here. I had a little mishap. Uh, I hit Control Page down to go to the next tab, and the key kind of got stuck. And so it loaded up a bunch of tabs that had been unloaded before. Okay. All right. Yeah, we are good now. Let's see. Sorry, I'm just looking for somebody. I'm just looking for somebody to raid right now. This person is AFK. Glad that they mentioned that they're AFK. Um, then there's another person. Okay, then there's another person. What is this person doing? Nope, that their chat is follower only. Never mind. Give me a second here. Okay, I think we'll go to this person's stream. Hold on. So they're doing some kind of like building thing. But yeah, yeah, that's gonna be it for today's stream. We made some good progress today. Hell yeah. And got a pretty good stream streak going as well. So that's awesome. But yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.